Hello everybody, my name is Mrs. Beck and today we are going to talk about Segment Addition Postulate. So let's kind of review about different types of lines. Let's look on the bottom first. We have a line, and this is a line pretty much that extends in either direction and it keeps on going forever. There is no end. The next type is a ray, and this has an endpoint on one side and it extends in one direction forever. It keeps going. So we have an endpoint, but then it also extends. Now the next type is a segment, which is pretty much what we'll be discussing today. A segment has two endpoints. It ends. It's a portion of a line. It doesn't go off any direction, doesn't keep going, it ends. It has two endpoints. So we're talking about the segment addition postulate, which says if 3 points A, B, and C, which we have A, B, and C, are collinear, and B is between A and C, then AB plus BC equals AC. So let's do a quick example. So on here we have AB and then BC, a whole entire line. Let's just say that AB equals 4. We'll just write a 4 there. And we'll bring it down here too. So we have a 4. And BC equals, let's say, 2. So I'll put a 2 there. How long is the entire segment from A to C? So let's use our formula. AB, which equals 4, BC, which equals 2, equals the entire line, which we can easily see is 6. Now, they're not always going to be this easy. Let's do another example. And if you see at the top, I have the formula for this. Let's look at this one. So this one says that the entire segment, there's no dots there, the entire segment is 28. So what we need to do is think of two numbers that are going to equal together to equal 28. So let's use our formula, AB. So let's pick a number for A to B. Let's say it's 20. What can we add to 20 to make 28? Easily you can see that it's 8. So 20 plus 8 equals 28, which is the entire line. Again, that one was pretty simple. So now this is when we're going to get a little bit harder. So if we can see, you can see that AB is 20 and BC is X. It's an unknown number. But we see that the entire AC equals 50. So let's use our formula. A to B is 20 plus BC. Well, we don't know BC, so we're just going to put in an X. Oops. We're going to put in an X. And we know what the whole thing is supposed to equal, so we're going to set that up equal to 50. Now, this is just a regular algebra equation, minus 20 on both sides. X equals 30. So we know that this part here is 30. Now let's go to this next one. So now, same thing. We'll write our equation. We know that the whole thing equals 52. We know that one part equals 30, and we know another part is unknown. So we have X plus 30 equals 52. 30 from both sides. X equals 22. So we know that this X is 22. Again, these ones are a little simple. It does get a little bit harder. So let's look at this one. We know the whole entire segment is equal to 30. So let's write equals 30. We have our AB, which is 13, but we're missing this portion. And if you see, it's actually x plus 2. So we're going to add x plus 2. So what we would do first is combine like terms. So 13 and 2 is 15 plus x equals 30. Again, just a normal equation, minus 15 on both sides. X equals 15. So we know that x equals 15. So let me write that up here. X equals 15. Now, if we wanted to check our work, we could go like this. Just insert it into our formula. So for AB, we have 13 plus x plus 2, so 15 plus 2, and that all equals 30. So what's 15 plus 2 is 17 plus 13 equals 30. And we know that 17 and 13 equal 30. So we know that our answer is correct. So let's try another one. This one is a little bit harder. So same formula, you see it at the top. AB plus BC equals AC. So our AB this time is x plus 5. And our BC is 25. Now if you see, our equals to, which is our AC, is kind of different than what we've seen prior. So 2x plus 10. So what do? The first thing that we do, we should combine some like terms. So we have x plus 30 is equal to 2x plus 10. So x plus 30 and 2x plus 10. So what we do now is get the x's to one side. It's probably easier to subtract this x from that side. So then we're left with 30 equals 2x minus x is x plus 10. So then again, we just have a regular equation. So minus 10, I'm just going to write it over here because I ran out of room. X equals 30 minus 10, which is 20. So the answer for this one is 20. So basically what you're doing is you're finding this formula and setting up the parts. So AB plus BC equals the entire line, which is AC. So it's like you're going from A to C. Let's go to the next one. All right, so again, this one is a little bit harder. Same formula, AB. So AB is 24 plus BC. BC is 3x plus 12. And we are going to set that equal to AC, which is 5x minus 12. So our goal is to figure out what x is. So combine like terms. So again, we have 24 and 12, which is 36. So 36 plus 3x equals 5x minus 12. So it'd definitely be easier to add the 12 over here and add the 12 over here. So then we're left with 48 plus 3x equals 5x. Now to subtract the 3x from both sides equals, I'm going to move over here again because I don't have a ton of room, 48 equals 2x. Now we divide by 2, x equals 24. So easy. Take this, add it to this, set it equal to this, and that is your segment addition postulate. Last one. This one's going to be the big one. X plus 9 plus 2x plus 12 equals 6x plus 18. Alright, so let's combine some like terms. I see that I can combine x and 2x. That'll give me 3x. And I see that I can combine 9 and 12. That'll give me 21 equals 6x plus 18. So let's subtract 18 because that looks like it's a little bit easier. You want to take the smaller number away from the bigger number. So we're left with 3x plus 3 equals 6x. Now we're going to subtract the 3x from over here and bring it over to this side, because again, taking the smaller from the bigger, so that leaves 3 equals 3x. Now 3 equals 3x, so we know what to do now. Divide by 3, divide by 3, x equals 1. Again, we take AB, add it to BC, get AC, the entire line. So what did we learn? We learned the segment addition postulate, which is AB plus BC equals AC. It's to combine parts of a line, if there's 3 points, and compare it to the whole to figure out the length of this one, the length of this one, the length of this one. Usually 1, 2, or 2 are given. So yeah, that's what we learned today, segment addition postulate. Hopefully you learned a lot from this video.